let's look at line graphs. So a line graph, along with a bar graph, pictograph, they are used to represent and plot data. Today we're going to look specifically at the line graph. So first let's get the definition of a line graph down. A line graph is used to record and plot numerical data such as temperature, scores, etc. So usually the data on a line graph are closely related, and they show how the data changes over a period of time. There's 3 different types of line graphs. I'm going to show you examples of the 3 types of line graphs. Here are examples of the 3 types of line graphs. This first one here is considered a curved line graph. The middle one is considered a broken line graph. And then that third one is considered a straight line graph. These names are pretty obvious. The curved, you can see how it goes uphill and then back downhill. The broken goes down, up, down, up, down. And then the straight is a straight line. So let's pull up some data and let's practice making our own line graph. Okay, so here's some data. Let's call this problem number 1. And I want to make a line graph for these numbers in our data. And these numbers represent the average monthly precipitation in Kentucky. And that's according to rssweather.com. So looking at our numbers here, you might want to jot down this table. January through June, the first 6 months of the year. So January had an average of 3.28 inches of precipitation, February 3.25 inches, March 4.41, April 3.91, May 4.88, and June 3.76 inches. So if you're not a numbers person, or especially if you're not a numbers person, this data, you might not care about it too much. It might be kind of hard to picture. So that's why we are going to help you picture it using a line graph. So first, looking at our line graph, we would need a title. We can just leave our title, Average Precipitation in Kentucky. In fact, let's move this down a little bit so we can officially put in a title. Right? Okay, so now you can see the title over my line graph here, Average Precipitation in Kentucky. You might have to go ahead and draw your own graph, or maybe you can use some graph paper. Okay, next we need to, at the bottom of our graph, we need to fill in the labels. So January, February, March, April, May, and June. So at the bottom here, let's start with January. Next is going to be February. I'm going to skip a line just to spread out our data a little bit. Then next is March, April. Next is May, and finally June. So those are our labels for the horizontal axis. Now let's look at the labels for the vertical axis. Those are going to be in inches since our data is in inches. Our data is pretty close together. I'm just going to go up by 1 inch each time, just like the months at the bottom, the horizontal axis. I'm going to skip one between each inch on the vertical axis, so I guess I'm going to go up by 0.5 each time. I'm just going to mark every 1 inch. So 1, probably up to 5. So this first dash mark here is going to be 0.5. And then the first one I'm going to mark is 1 inch. And then I'm going to keep going up to 2, 3, 4, and 5. So there's our labels on the side. And we need to mark that those values represent inches. So I'm going to just write that on the side, that these values represent inches. Now let's start plotting our data. So for January, it's going to be right on this vertical axis here, our first point. It's going to be at 3.28. We're going to be approximating here, but 3.28 should be between 3 and 3.5, so approximately here. Okay, then for February, we're going to put it right on this line here that represents February. So 3.25, so almost the exact same as January. Move that over a little bit. March, 4.41, so a little bit of a jump for March. So 4.41 will be between, again, 4 and 4.5, but a little bit closer to 4.5. April, 3.91, so a little bit of a dip for April, right under 4. May, 4.88, so above 4.5, but not quite to 5 inches. And then June, 3.76, so going back down to 3.76, that's almost exactly halfway between 3.5 and 4. So we have our points plotted here. This is a line graph, so we need to see the lines that connect these points of data. You will want to grab a straight edge to connect these points to make it very neat. I don't have a straight edge to use, so I'm just going to do the best that I can. We're going to connect each of these points starting between January and February, then connect February to March, March to April, April to May, and then May to June. So just a good way to picture our data here. I made a bigger mess, so I was trying to fix it. There we go, that'll work. So this just helps us, again, picture the data so we can quickly see the highest, the lowest, where it goes up, where it goes down. So looking at this data, I want us to answer a few questions. First question is, okay, so I went ahead and grabbed all of our questions. Let's answer a few questions here concerning this line graph. First question, what month had the highest precipitation? So we could use our table of data here, or we can use our line graph. And since we just spent all that time working on our line graph, let's go ahead and use the line graph. We can quickly see that our highest point is the point here. And if we look down, we can see that that occurred in the month of May. Okay, question number 2. What month had the lowest precipitation? So again, using our line graph, we can see that there's almost a tie. January and February, both pretty low. February is a tiny bit lower than January with 3.25 inches instead of 3.28 inches. So your answer for B should be February. Question C, what type of line graph is this? So if you recall at the beginning of the lesson, we looked at a few different types of line graphs, curved, broken, and straight. And you should answer that this type is broken. Many hills and valleys that we see here, going up and down, back up and back down. What is the range of the data? You might not know how to find the range of data. It's very simple. You take the highest value and subtract the lowest value. We will have to consult our table of data for the answer to this question. Since our line graph over here is just an approximation of values, it's hard to get the exact values to subtract. So instead we're going to look at the table. So over here at the table, look at the highest number, which we already know occurred in May, so 4.88, and subtract the lowest that occurred in February, 3.25. So if we subtract those values, 4.88 minus 3.25, we should get 1.63, and that is what is known as the range of the data. It's how much the most varies from the least. Okay, and then E. How much more precipitation was there in May than in January? So pretty similar to what we just did. How much more? Anytime you see those words, you should think subtraction. So you take the value that occurred in May, again 4.88, subtract the amount in January, 3.28, and it should be very close to our answer from D. 4.88 minus 3.28 is 1.6, and that is inches. And then lastly, what was the total precipitation? So whenever you see the word total, you should think of addition. We're adding all of the numbers together to find the total. So we'll do 3.28 plus 3.25 plus 4.41 plus 3.91 plus 4.88 plus 3.76. I'm not going to write all of that out because I'm almost out of room down here, but just make sure you're thinking about addition when you see the word total. So the total, if you add all of those values together, so up here in our table, if we add all those values together, we should get 23.49 inches. So that is how you design a line graph and just how to answer some basic questions dealing with a line graph.